Transformation and rigid motion. Anyone? So this mess got a sore throat. Love for you to help me out. Cool, Ryan. Thanks for making eye contact. Go for it.
Transformation is a function that maps a given figure from a created to a resulting figure to the image. Rigid motion is a transformation that observes size and shape.
You do the last one.
Reflection or flip is a rigid motion in which a figure and its image have opposite orientations. Thus, a reflected image in a mirror appears backwards.
Okay, so we're talking about taking a shape and transforming it in some way. It stays a rigid motion, which means the size and shape of whatever that figure is stays exactly the same. We're just flipping the orientation in some way. So when I talk about a reflection, what do you kind of think of when we say reflection? What's a mirror? What else? Anything else? A mirror is a good choice. Okay. Think about when you look at yourself in a mirror, right? Like you lift your right hand, but in the mirror, it looks like you're lifting your left hand, right? So it's flipped, whatever you have. So that's what we're going to practice today, is flipping different things. Where did my thing go? All right, we're going to watch a quick video. It's like a minute. Okay, what is going on with my computer? Okay, and it's just going to kind of explain what a reflection is, but in a little more like mathy terms. Okay.
Shorts. Reflection is a type of movement or change in a geometric shape. Think about when you look in a mirror. You see a reflection of yourself. See how your reflection appears to be the same distance from the surface of the mirror as you are? Also note how the left and right sides are reversed. The same is true with geometric shapes. When we reflect this triangle like this, the x-axis acts like a mirror. You can reflect all kinds of shapes, as long as you determine the line that you want to reflect on, just like a mirror. For example, you can use any line along the x-axis or the y-axis. You can even reflect the shape through a line using an expression such as x equals 1. In this example, the line x equals 1 is the line of reflection for the two triangles. You can use any expression to create a line of reflection anywhere. The way to make sure a shape is correctly reflected is to check that each point of one shape is the same distance from the line of reflection as the corresponding point in the other shape, and that it has corresponding sides and corresponding angles. Just like other transformations, you can record the coordinates of the shape and its image to demonstrate the reflection too. Reflection makes a mirror image. It's one type of movement for geometric shapes.
Okay, so we're going to practice now taking different shapes or taking different coordinates and reflecting them. I don't know what is going on here. Okay, so my very first one over here in reflection number 1 says we're going to reflect our points across the x-axis. Show me with your arms. Which one's the x-axis? Which way does it go? Good, right across. So I'm going to highlight mine. This is what we're going to reflect across. Okay, so first thing you're going to do is we're just going to plot these points right here on the graph, and we're going to make a shape. And I would like you to label them. We're going to label them as A, B, and C. Okay, so take a second, just plot those right on that line, right on that graph, labeling them, and then connect your pieces. This is B. And so it should make a triangle. And label your points too, A, B, and C. Okay, so this triangle, our starting triangle where we begin, this is called the pre-image. Pre-image. So it's where we begin. It's like our starting shape. Our ending shape, once we do some kind of transformation to it, so once we reflect our figure here in another moment, my new shape is going to be called the image. So you got the pre-image is where you start, the image is where you end up. So this one over here is going to be my image. Now, we're going to take this shape right here, and we're going to flip it across the x-axis. So right now, the triangle is like above the x-axis. So when I flip it, it should be the opposite orientation, but down below. And when we flip, it needs to be the same distance away from the line that we're flipping it over. So if you start with point A over here, we are how many units above that yellow line? 2. So what I'm going to do to reflect it is I need to go 2 units below the yellow line. Okay, same, like it's not moving, right? It's just flipping. So my x coordinate stays the same there. When I write my new coordinate, I put something called a prime next to it. It looks like a little dash, or like a little number 1 in the upper right-hand corner. It's called a prime. We put that there to show that this is now the image. This is a new figure that I'm drawing. So if I don't have the little prime next to it, that means that's where you're starting. Once you have this little tick mark or prime next to it, that's where you're ending up. Okay, let's do the same thing for B. So the B point is how many above the yellow line? 3. So I need to go which way? 3 down. 1, 2, 3. Again, I'm going to put a little prime next to it to show it's a new point. And now what's going to happen with point C? It's going to stay right there exactly because it's not going above or below that yellow line. So that point is also my C prime. So take a sec and connect your points. And you should see it's the exact same shape, exact same size. It's just flipped. And if it's a little wonky, that's okay. Human error. We're not perfect. I mean, I'm perfect, but we're not all perfect. It's okay. All right, now let's look at the coordinates. So if you're looking at this new point, A prime right here, what are the coordinates of that point? Good. 3, -2. Okay, what about B prime? -1, -3. Okay, and last one, my C. 1 and 0. That one didn't change. Didn't go anywhere. Okay. Now I want to see what the rule is. The rule. So now, if I look just at, let's ignore everything else. Let's just look at the A coordinates. What do you notice is happening? Whoa, one person. Kiki. The Y became negative. What about the X coordinate? Stayed the same. Okay. Well, does that work for the second one? Oh, yeah. Wait. Whoa. The X stayed the same. The Y became negative. But what about the last one? Well, why didn't the Y become negative?
That's the point where we're going to make it happen.
No, I don't know. Why not? Why can't you make this a negative? Because it's a 0. You can't make a 0 a negative. Okay, so my rule, what you're saying, is that my X coordinates stay the same. Okay, so my X's stay the same. What happens to your Y coordinates? Now they become negative. But what if I started down here? Then they become positive. So are they becoming negative, or what are they really doing? They're changing what? They're changing signs. Yeah, good. So my Y's are going to change signs. So my X's stay the same. My Y changes signs. So that's the rule in words. In math terms, when we write it as something called mapping notation, that means you start at X comma Y, and I want to write that my X's stay the same and my Y's change signs. So to write that, I'm going to keep the X the same, And then I'm going to change my y value. So I'm going to put negative y. So that negative does not mean make it a negative. That negative means change the sign. Good. So now you have reflected over the x-axis. Not bad, right? Picture should stay the same. It's just the orientation is flipping, right? It doesn't get bigger, it doesn't get smaller. It's just flipping. Okay, questions so far? Feeling okay? Let's try the next one. Reflection 2, you're going to reflect across the y-axis. Show me with your hands which one's the y-axis. There you go, good. So this time we're going to reflect across this line right here, up and down. Now, the pre-image, these are exactly the same as this one. So take a second, just redraw that exact same thing, and it's the same pre-image for all 4 of these. That's not going to change. So take a sec, just plot those points again, make your triangle. 3, 2. If you're a super overachiever, you can go for the other 2 as well. I do. All right, so it's the same pre-image, but this time, you're flipping over the y-axis. So instead of me flipping up and down, now you're flipping right and left, back and forth. Okay, so who can tell me where I should put my new point A, my A prime point? How do I flip it to the other side? Ryan, what do you think? Good. So I'm taking it from here and you're now flipping it to the left side, right? It's to the right of the line. Now we're going to flip it to the left of the line. So it's to the right 3, so I go to the left 3. And again, make sure when you write your coordinate, you put the prime next to it. If you forget the prime, it's going to be counted wrong. This is my image. Okay, who can tell me which way I should go for the B? So we're doing the opposite. So right now, is the B on the right of the line or the left of the line?
I was gonna ask this, so it's gonna
Well,
go that way or not? It's gonna stay.
no, so if it has to flip, right? We're trying to reflect the whole image. So just because this is on the left side, I still have to flip it to the other side, which would be which way? Yeah, I'm going to go to the right. Right over here. Here's my new B point. Okay, and now my C is to the right of the line, so I have to go -1 to the left of the line, right over here. And now you should see dun, 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 dun. It has reflected. It's okay that it overlaps. There's nothing wrong with that. It's allowed to overlap.
Are we going to see a lot of that where it overlaps?
Yes. Most of the time it's going to overlap. And like on your final exam, I think all of them overlap, which is wild, but. Okay, now I'm going to write the coordinates. So my A prime is -3 and +2. My B prime is 1 and 3. And my C prime is -1, 0. Great. Great. Bless you. All right, so again, excuse me, let's do the same thing. What seems to be the pattern? What are you noticing? The X changes what? X changes signs, right? So if it was positive, it becomes negative. If it's negative, it becomes positive. And what happens to the Y's? Good. My X's change signs. And my Y stays the same. Sorry, I know it's super small.
So will it always do that?
Always.
When
So-
they ask like, oh, we're gonna do X, or then we're gonna do Y. Okay.
So if I ask you to reflect over the y-axis, yes, x changes signs and y stays the same. So if I were to write it as a mapping notation, x, y becomes, what should I write over here? Perfect. You are catching on. You see exactly what's happening. Good. Good, 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 good. Questions so far? Grand. All right, reflection 3. Take a sec. Plot your pre-image. It's the exact same pre-image. So plot that pink one like I have. Do it again. Reflection 3. And label it exactly the same. Pre-image.
So is this one gonna flip? So the bottom left.
Kind of. Got the right idea. Okay, so this time it says reflect the points across the line y equals x. Y equals x. Now, that means it's a positive line, and it's pretty much a diagonal, and it's going to kind of cut this graph in half. So that means whatever point you put in for x, you should have the same point for y. So that means if I plug in a 1, 1, 2, 2, 3, 3. So essentially, the line that you're making is this like perfect line, whoa buddy, straight through the center, diagonal. So that's what this line is right here, y equals x. And then it goes -1, -1, -2, -2, -3, -3. So it's this like diagonal line. Yes.
So the fourth one, would it be this way?
Exactly.
Okay.
So reflection 4, when we get to that, one's going to go like this. Dun, 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 dun.
Can it be swapped? Like say the X and then the Y would be the same. Why are you looking at that?
Because you got the right idea.
Oh, just say yes, one.
Well, no, I want to say, we'll get there. So here's what's going to happen for reflection 3. We're taking this picture, oh my gosh, and we are flipping it across that yellow line. It is definitely going to overlap for sure. Sorry. So think about it like if I were to fold this paper essentially on this yellow line right here, this point, like the B on the left, would now come bink, all the way over here to the right. And this point A that's to the right would now have to go to the left, and so on and so forth. So it has to flip sides. Does that make sense? Yeah. So, for example, if I take point A is 3, 2. It is like halfway across this yellow line. If I go the opposite way, it's right over here. And that's at +2, +3. So without doing anything else, just look at the points. What looks like is the rule. I went one over. What happened from here to here? Yeah, the X and the Y trade places. That's it. So the signs don't change, they just trade places. So point B is at -1, 3. If they trade places, what does that become? 3, -1. Good. So 3, -1. Here's point B down here. B prime. It looks weird, but, and then again, C essentially gets swapped over this yellow line here. C was at 1, 0. What would be the new point? 0, 1. Good. This is C prime. So again, it has to essentially swap places. If it's to the like right of the yellow line, bless you, now it has to go to the left, and so on and so forth. So again, it's overlapping big time. But again, it's the same size, same shape, it's just getting flipped. So the rule here is that my X and Y trade places. X and Y trade places. So if I were to write it as a rule, what would that look like? XY becomes what?
YX.
YX. Good, they're trading places. Now my guess is you might be able to figure out what the rule is for the next one without even graphing it. Maybe. Let's start just like we did before. Same thing. Notice we're doing the same thing over and over and over again. Start with your pre-image and label the points. 3. Should get really good at drawing this triangle at this point.
Which place is this or sign?
This one.
Will we get a different image instead of a triangle?
Yes.
Okay, like guaranteed on like almost every question, different image? Or
Yeah. Yeah. It'll be a different image. I was just trying to keep it the same right now just so you could see what the difference was between them all.
Okay.
But yes, you will get different ones as it moves forward. Aiden.
The image the entire period or the entire quarter of the year. It's one triangle.
I mean, that would make life very easy if I did that. I gotta make life hard. Come on.
I remember this last week.
Like, wow, this is the same thing. Who would have guessed? Okay, Aiden, what did you say the rule was? You already kind of figured out? Okay, they switch places and they switch signs. So notice how this whole triangle is like above this yellow line. You now need to flip it to be below this yellow line down here. So your X and your Y's will trade places and they'll change signs. So if you were at 3, 2, if you trade places and change signs, what does that become? Perfect. -2, -3. Good. Label that. It's easier if you do the signs first and then graph it second. Okay, what about, sorry, I should label this A, B, C. What about point B prime? Trade places and change signs. Good. So it was -1, 3. It now becomes -3, +1. Oops. That is your B prime. And then C prime went from 1, 0. What does it become now? 0, -1. You can't switch the 0, right? It stays the same. So it's a 0, -1. And it's right here. And again, you should kind of notice, whoa, that was bad. It's the same picture, but now it's been flipped across that line made negative. So my rule is your X and Y trade places and change signs. Good. So if they were positive signs, they become negative. If they were negative, they become positive. So writing it as a mapping rule, how would I write that? XY becomes what? Good. -Y, -X. Perfection. Okay, so now this little section down here says, let's summarize our results. So we did all that work, and this is the most important section right here. I'm just straight up copying what I had before. So reflection 1, to reflect across the X-axis, the x stays the same, y changes signs. To reflect across the y-axis, x changes signs, y stays the same. Reflecting across the positive line, y equals x, they trade places. And reflecting across that negative line, y equals negative x, they trade places and change signs. Okay, so now, what? I know, I missed. It's been a long day already.
Well, the second video.
I know. So your homework for tonight is the back side. Now on the back, here's what happens. It looks like a lot, but it's really not. For numbers 1 through 4, you don't have anything to graph. It says the reflection, all you have to do is rewrite the new points. That's easy. For 5, 6, 7, and 8, you've got some reflections. I have labeled the points for you. Sorry, it got cut off over here. But you're going to write the original points, you're going to reflect it, and then write the new points and graph it as well. So notice that 5 and 6 have the same pre-image, and that 7 and 8 have the same pre-image. Okay, so when you go to write those down, they're the same. Question?
For 7 or for 5 through 8, do you have to graph it or can you just write it down?
I would like you to graph it because that's a good way to check. So here's my suggestion though. When you do 5 through 8, write the coordinates first, graph it second. Okay? Do the coordinates first with the rule, graph it second. All right, so now we only have about 3 more minutes. This right here, we are going to check in class tomorrow. This is your first grade of the quarter right here. In class. All right, I'll even write that at the top. Check in class. Friday, 10:15. So tomorrow we will check this first, and then the second part of class tomorrow, we're going to do some IXL practice with this. So you need a computer and or a phone tomorrow. Worst case scenario, we got the really bad computers in the back, but if you have your own computer or a phone, I suggest you bring that with you tomorrow. Okay? All right, thank you. You guys did fantastic today, as usual.